We are very excited to have you with us to talk about how Itaú Unibanco leveraged AWS Shield Advanced to combat DDoS events. We know that you are here to know more about Itaú Unibanco, one of the largest financial institutions of the world. You're going to have a chance to. But before, let me introduce myself. My name is Guilherme Greco. I'm a Principal Solutions Architect at AWS. I'm based in Brazil. And today, I am with other co-presenters that I want you to meet them as well.
I'm Douglas Lopes, Solution Architect Specialist in Edge Services.
I'm José Tiburcio, a Security Architect at Itaú Unibanco.
Excellent. Let's go ahead and get started. In this session, we are going to explain to you concepts and trends of DDoS attacks and how to use AWS services to protect your edge. By the end of this presentation, you're going to have a better understanding on how to implement DDoS protection using AWS Shield Advanced. But even better, you're going to have a real use case for large enterprise, such as Itaú Unibanco, who has thousands of public endpoints across thousands of accounts. But before getting started, I have a question that keeps many executives and technical leaders awake at night. How much would 60 minutes of downtime cost your business? The impact of downtime goes far beyond financial losses. Of course, you have to consider, for instance, lost revenue from transactions that can be processed, lost productivity across your organization, but the most important impacts are the damage in customer trust and reputation, and the long-term impact in customer confidence. Based on this, your online presence is not just a convenience, right? This is your real business. When we have a DDoS attack that succeeds, every minute of downtime is devastating for customers, and the attackers know that very well. With that being said, I have another question. Show of hands if you are using AWS Shield Advanced to protect your edge services against DDoS attacks. Okay, I can see that some people are using Shield Advanced, others are not, which means that both of you are in the right place because this is exactly what you're going to cover today. I'm going to pass through some DDoS statistics, concepts, and trends. And after that, I'll hand over to Douglas, who will deep dive on AWS Shield Advanced implementations. And then we will hand over to José Tiburcio, who will describe Itaú Unibanco's journey to protect thousands of public endpoints against DDoS attacks in a decentralized and distributed model for financial services. This is going to be awesome. And then we are going to have some takeaways and research. But before, let me recap some concepts and explain what a DDoS attack is and why it is a critical concern for organizations. This is a typical AWS architecture. No secrets behind the scenes. But just imagine that you have an online store. In a normal days, your customers just easily walk in and walk out, but suddenly you have thousands of customers, not just to shop, but to block the entrance. This is essentially what a DDoS attack does, right? And as you can see in the diagram, those kind of attacks are distributed because they come from multiple sources. They don't have just one location, but hundreds of thousands of compromised systems, often IoT devices, computers, servers, all of them coordinated to overwhelm a target. DDoS attacks are from infrastructure side, such as UDP flood, SIEM flood, or from application side, such as HTTP flood, DNS query flood, among others. But once you're going to have a 300-level conversation with Itaú Unibanco, I need to bring more details about DDoS attacks. And to do that, I will explore AWS DDoS statistics to explain how AWS supports DDoS attacks at scale. We are going to have some numbers in terms of volumes. I will describe some outliers, such as the highest request per second attack, throughput, packet per second. This is going to be some kind of overview about AWS DDoS threat landscape, okay? In the last 12 months, we had more than 700,000 attacks, which means that every day, AWS detected, mitigated, or blocked more than 2,100 attacks. This is a huge number. Moving out to the outliers that I mentioned before, the highest, largest request flood attack passed more than 7 million requests per second. And then the largest bandwidth-heavy attack almost reached 1 terabit per second. Moving to application-based attacks, the largest packet attack passed more than 1 billion packets per second. You can see that we have a huge volume of attacks hitting AWS global network infrastructure. Now, let me share a dashboard that has an interesting comparison between application and infrastructure-based attacks. The data comes from 2021 until today, 2025 Q1, and as you can see, application-based attacks had an increase over the years, especially because of the cloud, because of now new applications can be easily deployed, right? We have more online endpoints, which means that we're going to have more targets that justify the increase of application attacks. But in 2024 Q4, we had a change in the behavior. Where the lines were crossed, you can see that application attacks decreased, infrastructure attacks increased a little bit. So, which means that this is an interesting insight about how the attacks are evolving, because in 2025 Q1, they moved to a more balanced perspective, but the volumes are still growing. A right way to read this dashboard is that now we have more sophisticated attacks that can explore multi-vector attacks as a blend of infrastructure and application. That's the reason that we can see some kind of balance between the numbers in the last quarter. But I want to deep dive more in those kind of numbers. In your left-hand side, you have the volume of DDoS attacks or events related to the infrastructure. We had more than 307,000 events for the infrastructure. On the bottom, you can see Q1 until Q4, which represents 2024, right? But when you move to 2025 Q1, we had a spike. So this is represented in the dashboard that you saw before. Moving out to the right-hand side, to the application-based attacks, this is interesting, right? So we had a similar number, more than 307,000 events. But now the behavior is a little bit the opposite, right? Because in Q1 2024, we had a spike, and now the number decreased, and we are seeing an increase in 2025 Q1, which means that the balance of infrastructure and application-based attacks drive us to a multi-vector-based attacks tendency, right? Moving to the largest request flood events, we have data from 2019 until 2024. We see that in 2023, we had an outlier, right? More than 155 million requests per second. Of course, when you move to 2024, the number dropped. It was an outlier. But the message here is that if we compare 2029 until 2024, we do have increase in requests per second attacks. Now, bring this in a different perspective with different dimensions. More than 30% of the attacks was request flood attack, which means this is the basic kind of attack, right? Attackers are just sending high volume of traffic to the targets. Then we move to separated vectors for the infrastructure, mainly packet flood until reaching scene flood. As I mentioned, the attacks are increasing exponentially, but what is interesting to bring to our session is that now they have changed in terms of duration. More than 80% of the attacks, the duration of the attacks lasts less than 5 minutes. And within this number, more than 41% is lasting less than 1 minute, which means that those kind of attacks are challenged because they were designed, developed to give to you disruption before your mitigation process kicks in. This is challenging for AWS as well because we have to increase our threat intelligence in terms of malicious traffic, exactly to avoid customers' outage before the attack reaches the customer, right? In terms of movements, as I mentioned it, and you can see that in the dashboards, we can see a tendency moving from simple floods to multi-vector attacks. Again, now attackers can have infrastructure and application-based attacks simultaneously in the same attack. This is a challenge because you block one vector, you are going to have another one. And then we are seeing IoT botnets as a tendency as well, especially because of 5G and more connected devices. Now attackers can have a chance to have compromised devices and create an army and perform a massive attacks to targets. As I mentioned before, every day across AWS infrastructure, we detect, mitigate, and block DDoS attacks. With a large public network footprint, AWS has insights into activities on the internet in real time. A large amount of traffic across the internet must be gathered and analyzed for threat intelligence to combat DDoS attacks. Based on this, AWS has a unique visibility in terms of traffic because of our size and scale. With that being said, I will hand over to Douglas.
Thank you, Greco. Well, before you listen to Itaú and see what they are doing to protect their workloads against DDoS protections, we're gonna talk a little about how the protections are done by AWS. Actually, we have services that are dedicated to protect our workloads against DDoS, and these services are called the Edge and Perimeter Protection Services. Among the services, we have Amazon CloudFront, which is our delivery HTTP-based content service. And also we have Amazon Route 53 in or DNS service, and also AWS Global Accelerator, the services that deliver TCP UDP communications. The perimeter protection services, what we call perimeter protection services, are services that are related to this, are integrated with this. These are, for instance, AWS WAF, or Web Application Firewall, and AWS Firewall Manager, that are integrated with Shield or standard DDoS protection. And talking about these services, AWS Shield has two tiers in AWS. The AWS Shield, that is the standard protection, as I mentioned, and also AWS Shield Advanced, that can extend these protections to the other levels. Shield, or standard DDoS protection services, the detections and mitigations permeate the entire network perimeter, including the POPs that extends our network, and where Shield implements protections and against the attacks in the services, the edge services like Amazon CloudFront and Route 53. And the protections in these POPs are in line. It means that the detections and mitigations will occur immediately. And many techniques are used to detect and block these attacks, including packet validation and distributed screening capacity. Also, the protections extends to the border of the network that is near to the regions, which makes that the protections makes that the majority of attacks to be blocked even before the customers be impacted. Well, however, customers that need greater protections and ability to customize the DDoS protections, they use Shield Advanced. And Shield Advanced incorporates the Shield's protections, but also extends this more with, for instance, the possibility to use Web Application Firewall more extensively. Also, it allows you, it's included in its package, the possibility to use Firewall Manager, the REST Firewall Manager, that allows you to centralize the compliance and the enforcement of the security policies among your resources to protect with Shield Advanced and to protect with WAF. And the customers that use Shield Advanced are benefiting from many features. One of the features that they can rely on is the increased visibility. It allows them to have access to metrics for monitoring events and alarms. Also, they have access to the 24/7 team experienced in DDoS that we call SRT, or Shield Advanced Shield Response Team, that allows customers to have access to this specialized team of support. And also, customer has another very interesting feature, that is the cost protection for scaling during attacks. It means that customer can scale without incurring elevated costs because they are absorbing the attacks, absorbing the capacity, the high volume of these attacks. Turns out that some customers have deployed Shield Advanced or are planning to do it so. However, they are not taking advantage of all what Shield Advanced's potential. and I'd like to share some information that can help them to extract most of it. When you are deploying Shield Advanced, there are some processes that you have to follow. And among these processes, these steps, the first one is on the DOS architectural resilience review. Many customers are using professional services like AWS ProServer, or sometimes they are using partners to do it, but sometimes they choose to do it by themselves. And in this case, they might not be following the best practices, so they can be reliable and resilient to this against the DDoS attacks. And to follow these best practices, for instance, among the best practices that we recommend is to reduce the attack surface and design a scalable architecture, which includes the use of multi-AZ strategy, the use of auto-scale, and also, in addition to this, the use of edge services, AWS Edge Service that I have mentioned before, Amazon CloudFront, Global Accelerator, and also Amazon Route 53. And with this, you can take the advantage of the great capacity of these services to absorb large distributed attacks. Well, and when you are looking for do this review, know that you can get help from AWS. If you should talk to your account team and ask them for a specialist SA to assist you with this. It's good to have someone that can help you to pinpoint important procedures to make an architecture that is resilient and compliant with Shield Advanced benefits like the cost protection for scaling during attacks, for instance. Well, when you have a single account, is a very straightforward process to onboard Shield Advanced. As I mentioned, first thing, important thing, is the DDoS architectural resilience review, and then you continue with the subscription to the services, choose the resource that you are going to protect, authorize the AWS SRT team to have the proper access. It's important to mention here that you should have the business or enterprise subscription of the support in order to have access to this team. And then enable the proactive engagement. The proactive engagement is, imagine when you, during an attack, or even before you not see this, you are being contacted by the security team to identify where is the impact. And also, in the end, you should complete the contact list for escalation. Well, but sometimes you, even if you have the proper level of support, or even if you have enabled the proactive engagement, the proactive engagement is not engaging. And it could be because the health checks are not being configured. It's important to configure the health checks because AWS Shield Advanced is unable to get the signs and the evidence that your application must be impacted without these health checks. It's important to include this because it can adjust the attack detections properly, and the proactive engagement can work as is expected. Another interesting feature is that customers that use Shield Advanced has access to is the for rules, which are the synthetic simulated attacks that ingest statistics and metrics that can be used to test the incident response process and give your visibility of how it's going to be in the console, for instance, when you have a real attack occurring. So it's important to use this tool. Finally, well, when you have one-on-one account, it's easy to configure it to onboard Shield Advanced, but it might be a challenge when you are in a large environment and large account, a large organization where you have many accounts and many resources. So for do this, you should use the AWS Firewall Manager, AWS Firewall Manager is integrated with the AWS organizations and AWS config, which allows it to detect when a resource is included in your organization and mitigate if it's not compliance with the protections defined by the security team. As for instance, the protections implemented by Shield Advanced and AWS WAF. And also, today, AWS Firewall Manager allows you to use the retrofitting of firewall of AWS WAF rules, what allow you to maintain the rules that were applied by your application teams, but also including the rules that was defined by the security team. And, well, if you have a high complex organization that imposes challenges to onboard the process, the good news is that there are tools that can be used to help in this process. We have launched the one-click deployment of Shield Advanced, which allows customers to use infrastructure as a code tools like Terraform and CloudFormation to implement Shield Advanced prerequisites and also implement the Firewall Manager to protect the resources with Shield Advanced in AWS WAF. Another interesting tool is the automations for Firewall Manager that allows you to centralize the auditing firewall rules across your accounts and organization. And in this automations solution has the possibility to use a workflow that will help you to deploy automatically Shield Advanced as well, but also has another workflow inside it that can detect if your resources are not using health checks, and it can create the health checks based on your resource and implement it if you are protecting a resource with Shield Advanced. Okay, so that's insights I certainly know that it will help you to extract most of Shield Advanced and allow you to protect better your resource with Shield Advanced in large environments. Now, I will invite Jose to the stage.
Thanks, Douglas. First, let me introduce you to Itaú Unibanco. We are a universal bank with over 100 years of history. We offer financial services tailored to various market segments. We are also the largest financial institution in Latin America and one of the largest in the world by market cap. We are the most valuable brand in Latin America as well, and we have over 96,000 employees distributed in Brazil and overseas. We are undergoing a substantial digital transformation to modernize our processes and solutions. And to achieve this goal, we organized ourselves in different teams. The first team is the Cloud Foundation team that is responsible for essential cloud services, including AWS account provisioning, network, and basic connectivity. Next, we have the platform teams. We are responsible to develop infrastructure as code modules, standards, and blueprints that reduce the cognitive load of our developers so they can focus. And using those technical capabilities and cloud services is the business team, which creates the business value for our end customers. We have seen a reduction in costs, in transactions costs, compared to previous years, as well as a notable increase in the number of deployments that we do compared to previous years as well. And we have more than 6,000 AWS certifications, which makes us the most significant AWS certification program in the world. Supporting all those teams is my team, which acts as a security pillar and offers services and controls to support the platform teams, the business teams, and the cloud foundation teams. We have a large AWS footprint that powers this operation. We have achieved a significant scale on AWS since the inception of our cloud migration. We have 5 AWS organizations in production environment with over 11,000 AWS accounts and more than 40 million configuration items that it supports more than 100 communities of practice distributed in 300 release trains and with over 2,700 squads and more than 5,700 business services. These numbers reflect the magnitude and complexity of our cloud operation. And to reach it, we designed a scalable landing zone. Our landing zone is responsible for scaling AWS accounts to support applications belonging to multiple business units. We have integrated our ITSM portal where the product owners and developers can request new group of accounts. As you can see, the control plane is responsible for orchestrating the account provisioning, calling AWS Control Tower and AWS Service Catalog APIs to launch new governed accounts. After that, the platform teams using delegated accounts inject controls, governance, and frameworks into those product accounts. This environment is organized so that the landing zone can expand with new management accounts as we require. And in this way, we can create additional product accounts to support applications in our business units as well. So, given our scale, we needed to standardize and control our edge services exposures. So that's when we will dive deep on our journey for exposing those applications using AWS Edge Services. This initial phase was crucial in setting a strong foundation. I will explain to you how we implemented Edge Services protection against DDoS, starting with this centralized approach. To support the business units that need to expose public-facing applications using AWS Edge Services, we've created a centralized inbound account, which is maintained by the SecOps team. We've started with CloudFront, ALB, API Gateway, NLB, and S3 bucket integrations. And to support ALB and NLB, we've created a VPC where public subnets forwarded traffic to a private VPC endpoint, which in turn forwarded the traffic to downstream services. The business units using our landing zone self-service were allowed to create new product accounts, and they had complete control over their AWS infrastructure. Once they were ready to expose to the public internet, they needed to open a ticket to the SecOps team, which in turn configured the AWS Edge Services resources on the inbound account. Once we had everything in place, we needed to ensure that no direct access was allowed to our public face origins. So we wanted to ensure that only our CloudFront distributions could forward requests to the origins, thereby reducing the attack surface and centralizing the service exposure. For static web content, we used origin access identity, and so we can authenticate CloudFront access to the S3 buckets distributed in the accounts. While new applications were created, we gradually migrated from origin access identity to our origin access control to embrace the KMS support, and this is the standard for the whole organization. For API Gateway, ALB, and NLB, we explored different mechanisms, such as custom headers that used shared secrets, CloudFront IP ranges, and lastly, AWS Managed Prefix Lists for CloudFront, which allowed us to natively integrate with security groups, route tables, and Firewall Manager. We do know that CloudFront has VPC origins, and it is in our roadmap for the future. Now that we had protected the origins and the users can't bypass CloudFront from the inbound account. But remember when I said that we have a self-service that the developers and the product owners can create new product accounts, right? These accounts will scale out with new VPCs, new applications, using the pipelines to deploy applications across environments, from development to production. So we realized that we needed a way to create a governance for the DDoS and edge services that follows this development lifecycle. So we needed to give the ability to developers to launch their public endpoints in their own accounts. So to do that, we created an IP set that allowed access to IPs that belonged to AWS Managed Prefix Lists and to Itaú Unibanco's data center, as well as our AWS Egress Firewall elastic IP addresses, so that our applications and automations could have access to our public-facing services. This allowed our developers to create workloads in their accounts and follow every step from the process of exposing DDoS, applications to the internet, protected from DDoS attacks. We don't need to expose non-production environments to the internet. So by doing this DDoS governance, we could allow the developers to implement these public-facing services from the start, using development and staging environments to validate their application architecture and move on to production later. So now that we had the protection in place and we had everything under control, we started receiving heavy load from the internet and even from the internal applications who accessed our public-facing services. The network infrastructure was robust, but the applications themselves couldn't handle the traffic, resulting in outages. To mitigate that, we explored architectures for scaling out the environment. AWS Shield Advanced comes with DDoS cost protection, so we can be safeguarded against scaling charges resulting from DDoS-related usage spikes. So if any of those protected resources is scaled up in response to a DDoS attack, we can request Shield Advanced service credits through our regular AWS support channel. Itaú has thousands of applications, and just scaling the infrastructure will not absorb all the traffic. So the downstream applications can be impacted. And to manage that, we started exploring different mechanisms. So we moved the security protection to the application layer using AWS API Gateway rate limits. So we can fine-grain our API, we can much better control the API usage from our clients. But remember, that's not sufficient when you are protecting your application in the public internet. You also need, in conjunction with that, to use AWS WAF and the AWS CloudFront. So you can implement different rate limits and application geo restrictions to better suit your needs. So now that we had the governance and the autonomy we had to create these rate limits. So we set up a journey. We started to analyze the events that occurred during the year in Brazil. And we noticed that every major event, like the Mother's Day, Christmas Day, Salary Payments Day, and every other important day of the year, was when the traffic spiked. So we do an event management during the year so we can better prepare ourselves. We set the baseline for the application's exposure. And we've also worked with different application teams in the bank to create custom rate limits. Because as a large enterprise, you may know that we have integrations with different partners, call centers, third-party integrators, and we also have our own internal and external automations. So we needed to analyze the way that these applications worked so we could separate legitimate traffic from attacks. So after that, we set out to create our WAF rules with a list of priorities. We set out to create this strategic hierarchy of different WAF rules. At first, we have the allow and block IPs list, which allows us to block immediately malicious agents. We also are heavy users of Amazon Managed Rules with its IP reputation lists and anonymous IP list, which collaborates to our protection. And we also are users of marketplace third-party rules, which can help us, for example, dealing with OWASP top 10 attacks. We also have at the bottom of the hierarchy our baseline rate limit or our custom rate limits developed for each application use case. So let's revisit our evolving infrastructure scenario. We've successfully implemented the robust protections for our origins using the managed prefixes, the custom headers with shared secrets. We leverage the security groups, we leverage the route tables, and we've also established the application-based rate limits and implemented these rate limits to safeguard our endpoints against DDoS attacks. However, our environment continues to expand rapidly, and we are facing new challenges by leveraging the scalability of our landing zone. The growth in applications and accounts has led to an increase in the requests to our security operations teams. So it started to become a bottleneck. And this started to impede our cloud expansion. So we looked for ways to overcome these challenges. That's when we started to rethink our architecture. As we gained experience and maturity, we transitioned to a decentralized model. To address these scalability issues, we made a strategic pivot in our operational model. We decided to centralize the governance while distributing the execution. So this shift led us to adopt a decentralized approach for edge protection. So we maintained the centralized control over the policies and standards. We ensured the consistency and security across the organization. And meanwhile, by distributing the execution of the edge protection measures, we empower the individuals and the teams to implement and manage their own edge services within the established framework. This decentralized approach enables greater agility, faster response times, and specific application needs. To implement that, we used a delegated account for the AWS Firewall Manager, and we learned from the past when we implemented the centralized approach. So, similar to the inbound account, This Firewall Manager account is managed by the SecOps team. We use Firewall Manager to connect to AWS organizations to streamline our controls and governance. With AWS Firewall Manager, we can have a single console for managing this edge protection across accounts. We can create policies to manage AWS WAF rules, Shield Advanced Protection, VPC security groups, network firewall rules, and Route 53 resolver DNS firewall rules. From this central location, the monitoring becomes centralized through this single console. This consolidated view helped us to help the security team to maintain the controls consistent with our baselines. So the business units could scale out to multiple product accounts. And as we went on this journey, we learned a lot. We scaled a lot as well. As you can see, we have more than 7,000 CloudFront distributions, more than 350 load balancers and elastic IPs, more than 300 Route 53 hosted zones, and more than 10 global accelerators for products that does not support CloudFront integration. All of them protected by the Shield Advanced, launched in the product accounts, created by the business units and centrally governed by the security team. So that's fine, that's well. We've discussed this architecture, the best practices, the applications. However, having this protection alone is not enough. The security team needs to operate the edge protection. We could centralize governance, implement observability, and respond quickly in the event of DDoS attacks. Let me go back to our landscape. When we started our journey to protect the edge services, we had the application logs and security logs in the same product account. The application teams were interested in the application logs, and the security team needs access to the WAF logs, the AWS Edge Protection logs. So this caused an operational overhead for the security team, because they had to jump from account to account to perform basic tasks like ad hoc queries on the logs that were stored in each account S3 bucket. That's when we decided to migrate ourselves to use Amazon Data Firehose to streamline the logs to a central S3 bucket, where the security team could perform the ad hoc queries, and the application teams using their product accounts could focus on the app logs. Although we had access to this centralized bucket, we realized that we needed to integrate this information with our CM system, where we can perform a series of events correlations using event centralization from multiple sources. This provided us with an off-console solution that allowed the security team to access it without requiring to authenticate in each AWS account, so improving their productivity. So now that we had the WAF logs sent across accounts to this centralized bucket, we had created an automation to send those logs to our CM endpoint. We also enabled the Security Hub Firewall Manager integration, allowing us to centrally monitor all the findings from the product accounts and forward those to the CM as well. This setup enabled us to have a single pane of glass for logs and events, and allowed us to have observability in terms of edge protection. And if an attack happens, we already have the permissions for the AWS Shield Response Team, so they can access the WAF APIs and the logs stored in the S3 bucket. The SecOps team collaborates with the SRT team and the application team to initiate the analysis of the event. It is essential to engage the application team because they can provide, they can collaborate with us on traffic analysis, cost impacts, criticality, and specific app behaviors. So when an AWS Shield Advanced team arrives at our CM system, an automation automatically notifies the SecOps team. The SecOps team follows the predefined playbooks and runbooks specific for that scenario. For an identified ongoing attack, the team performs an immediate assessment to understand what is going on. And we verify all the details about the attack, like its type or its impact. We also check for performance issues that may be affecting our applications and services. And we review the automatic mitigations applied by AWS Shield Advanced and AWS WAF, including traffic filtering and rate limiting. Additional actions may be necessary. So, like adjusting security groups, enabling additional WAF rules, and etc. We also document it from the start. For identified subsided attacks, we perform a post-attack analysis review, including its duration, types of vectors that were used on the attack, the affected resources, and the effectiveness of our automated mitigations. We also conduct a resource assessment that allows us to take a picture of our resources and see that they display normal behavior and metrics. When the mitigation is in progress, we closely monitor the AWS Shield dashboard for real-time updates to track our applications and performance metrics and keep an eye on the resource utilization. We don't interfere with ongoing automatic mitigations, and we avoid making unnecessary changes to security groups and network ACLs. We also document any observed impact on our services. We also ensure that we are prepared for escalation procedures, keeping all relevant team members on standby and engaging with AWS SRT team as needed. To bring more context and understand the attack behavior, the security team can perform queries to the CM system using the event details attributes to search for specific patterns and sources of attacks. At the same time, the AWS Edge Services provides different metrics: AWS Shield Advanced, AWS WAF, AWS CloudFront, and AWS Global Accelerator that you can use to perform the analysis and as well as in your mitigation automations. So the goal is to gain a comprehensive understanding of the overall attack, providing a detailed view that will help the security team to quickly identify these patterns and signatures of DDoS attacks. So it also enables this identification of sources of the attacks and the effectiveness of our current roles, which is crucial for fine-tuning the automated mitigations. So this coordination between all the teams, the AWS Shield Advanced, the AWS SRT team, the security team, and the application team can go even further to coordinating with our ISPs and law enforcement agencies in Brazil and overseas. The volumetric analysis as well can help us plan our scale out and scale in strategies. Some practical examples of activities that we perform with the SR team include managing, for example, route tables to direct traffic to a black hole, or messing with the CloudFront cache behavior or geo restriction, or enabling geo-blocking, just for an example. We also can modify WAF rate-based rules or string match rules. After the remediation is done and the event is mitigated, we can now work with the post-mortem analysis. And we gather with the security and application teams to review what went well, what we could do better, so we can feed our current playbooks with new information that helps us dealing with future attacks. We also regularly perform fire drills with the AWS SRT team to simulate our alerts and automated mitigations. So let's recap what we've learned in our journey. Work with your rate limits. Discuss with the application teams the application behavior specifics. With that, you can create more specific rate limits for that use case. Analyze your business impact and be prepared to scale out. Adopting scale out and scaling strategies is important for you to better handle these DDoS attacks. Also perform a thorough review of the important events that you have in your calendar year to better prepare and handle these DDoS attacks and common threats that we may face on public-facing internet services. So do a post-mortem analysis that goes deep in the root causes of the attacks and that will allow you to feed the documentation and the procedures of your teams so they can act quickly next time. Also be aware of the friendly fire. As with every large enterprise, we have multiple applications that we execute to automate processes and to access public-facing services. So internal applications can perform denial of service attacks as well because of bad configurations or bugs. So be aware of that. And explore AWS Shield Advanced events that can help you automatically mitigate these DDoS attacks using the metrics that it provides. So thank you. I will hand it to Douglas.
Thank you, Jose. It was amazing to see all Itaú's journey and learn from them, for their experience. Actually, we have some takeaways, and among them, leverage AWS Firewall Manager. If you use centralized approach or decentralized approach, no matter, you must have used the Firewall Manager because it allows you to protect in scale. Also, reduce your attack surface, doing it by protecting your origin using edge services. Also, we have seen the importance of have a consolidated view or one pane of glass to monitor and to see everything that is happening. And when you are doing your documentation or procedures, patterns and playbooks, also training your team for incident response, use fire drills. Here are some links that you can get access to research shared in this session. And thank you for all your time, and I hope you have enjoyed the session and our event so far.